Okay, so this is the last problem from the exam. So we have this implicit equation here, and we're asked to find y prime. So we have to take the derivative of both sides of the equation. So the derivative of arctan of y cubed minus x squared over square root 1 plus y to the 6th equals the derivative of pi over 2. So now we use that the derivative of arctan is equal to 1 over 1 plus x squared. And for the second term, we use the quotient rule. So based on this, for this term, we'll get 1 over the argument squared. The argument is y cubed, so it becomes 1 over 1 plus y to the 6th. And then by the chain rule, we have to multiply by the derivative on the inside, which is 3y squared y prime. Second term requires the quotient rule. So we have derivative of numerator times denominator minus derivative of the denominator, which is 1/2 times this thing to the negative 1/2 times 6y to the 5th times y prime. Then the denominator from the quotient rule gives us 1 plus y to the 6th, and you'll notice that we get the same denominators here, so that's convenient. Then the derivative of the constant on the other side is 0. So let's group together the terms that have a y prime in them and move the other terms to the right-hand side. So if we do that, we'll get y prime times 1 plus 3x squared y to the 5th. Right, so I'm missing an x squared here, right? Because from the quotient rule, I also have to multiply by the first function on the top. This gets multiplied by 1 plus y to the 6th raised to the negative 1/2. And then the term we brought to the other side is 2x square root 1 plus y to the power 6. So to solve for y prime, we just have to divide by this big mess, and we get 2x square root 1 plus y to the 6th, all divided by 1 plus 3x squared y to the 5th times 1 plus y to the 6th to the negative 1/2. And that is the best that we can really do with this thing.